contact tracing applications. For the COVID contact tracing applications in a few countries and several regions, like for example, Scotland or Gibraltar in the UK, Ireland, Northern Ireland in the UK as well, and a few states in the US and a few other countries here and there. I'm a DevOps architect. We are hiring a lot, so if you're interested in working with us, we are remote friendly. So we're actually remote first. I think 5 years ago when I joined, was probably the only company hiring remotely by default in Europe. So it has become the norm now, but anyway. I am also a part-time lecturer at CCT College here in Dublin. I live in Dublin, technology geek, developer expert in GCP, particularly in Kubernetes, and member of the Node.js Foundation and the Security Working Group. I wrote these 2 books. If you want a copy of them, you can send me an email and I will send you a copy on PDF for you. No questions asked, so don't even buy them. And the first thing is I'm going to set up the context on what is the problem with COVID. So let's say you take a bus and go from your home into somewhere else, and it takes you half an hour, and you sit around a lot of people, and then 2 days later you test positive for COVID. So how do you notice, or how do you tell the other people that you are actually positive in COVID? So you can't, because you don't know them. Okay. There's another problem, which is everybody's talking about the herd immunity at 70%. But that's actually not true. That depends on the R number of COVID, which is how fast do the virus spread across people. And in general, the R in COVID is very high, or tends to be very high, because it's very infectious. But if the R was smaller, the herd immunity will be held at 60 or 50% or something like that. So that's why we want to break the chains of transmission. And the best way to do that is isolating people and isolating, like the lockdown. So in general, the contact tracing solution, what it does is targets people who have, or may have been positive, or may have been in contact with a positive person, so that we reduce that R number and make sure that the virus stays under check. In general, a close contact is considered when you are 15 minutes closer than 2 meters to somebody, and that's managed by the contact tracing API in Android and iOS. It's funny because when we started developing these APIs did not exist. So the first thing that the people who started developing this tried was using the general Bluetooth, but that didn't work in a few implementations, actually, because when the phone was going to sleep, and it will actually interrupt the contact tracing, and like even putting the iPhone in your pocket will cause the phone to stop tracing contacts. And then Google and Apple develop a new API, which is the contact tracing API, which will do that automatically. So this is the stack that we have in the server side. In general, AWS was the obvious choice. I think if you blindfold me and give me a keyboard, well, my keyboard, because I'm used to it, and tell me that I am on a terminal, I will be able to write the infrastructure without looking into the keyboard or the screen, because I'm a consultant and I do AWS pretty much every day, and I can actually go and do crazy things in AWS pretty much out of muscle memory. Serverless, I wasn't very keen on serverless in the beginning. I'm a big Kubernetes fan. I really like Kubernetes for several reasons, but in general, serverless, and we didn't use serverless Kubernetes in here, was all in all a good choice. I will tell you more about that. But I wasn't super keen on the beginning because, we all know Kubernetes very well. So why don't we just leverage that? Especially because we were under a lot of pressure to get this thing delivered. And we also made a heavy usage of Lambdas. What we used instead of Kubernetes was ECS Fargate, which is the serverless version of Elastic Container Service. And then the RDS database, we actually did not go for serverless in the database because it's not mature yet. When we started this, the version of RDS was 1.0. And the reality is serverless RDS has only gotten better in the version 2. And we were not super confident on that. So we kind of dodged that bullet. It would have been great, in my opinion, but it was hard to say at the time. API Gateway, it's involved here. I became the API Gateway expert of my company, and that's why the meme is there, because like API Gateway is fantastic, but it can be super complex as well, like super, super complex. And in general, the usual suspects, SQS, SNS, VPC. I've seen a trend as well, like, oh, we use serverless, we don't use VPCs. Well, you should, because that means even though it's encrypted, the data of your customers or your users will go in the internet, through the internet, and that's bad in every form. So yeah, it's one of these things that we found the hard way on security reviews. Serverless, spoiler alert, Lambdas are bad. The guy on the right, it's me trying to debug an error in a Lambda-based system. They are a super dangerous ally, so they can be very good for a few things, but they can be very painful for other things. In general, if you try to model your full system in Lambda, it's the 2021 version of let's use stored procedures. I'm sure every one of you have come across or still working with stored procedures in databases, and it's a big no for me. It's very hard to debug. I have no issues working in a system like that, but it becomes actually very problematic. My opinion is that Knative is going to eat the world. I don't know if you know what Knative is, but Knative is pretty much like a serverless implementation in Kubernetes. So if you ask me, what will you build your system in 5 years? It will be Node.js with Knative, all around. The problem with serverless in general is that debugging a distributed system based on messages, it's the first cycle of hell. It's just, when you're passing messages around and you expect things to work, it becomes super problematic. So if you are working in Node.js, which I believe you are because this is Manchester Node.js, so I will expect a good amount of people working in Node.js. When you are doing, the old style callbacks, and now with promises, it's a lot easier. But basically what happens in the event loop, it's message passing. So you pass messages into the event loop executes them, and then you get back the response in the form of a callback or a promise resolved or rejected or something like that. So now who never got caught by that raise the hand? I think nobody will raise it, because all of us have been caught into async messaging problems and nature things. Like at debug issues like, this thing is only failing sometimes, and it's because, somebody didn't put the data inside the callback and it was outside, or the promise was not resolving correctly and things like that. So imagine that multiplied by 10 in Lambdas and ECS and SQS and SNS. So it can be at the very least very challenging. So Lambdas are a pain in the majority of the cases, but in other cases are actually a very, very powerful ally, okay? So Lambda is the perfect async task runner. So when we calculate, like the way the application works is very simple. You have your phone. Your phone keeps the track of who has been in touch with. That means if you walk off the street and you're walking for 15 minutes closer to 2 meters to somebody, your phone will write down the anonymous ID, the random ID of that phone in a database locally. And then every 4 or 6 hours, your phone goes to the server with the authentication token, downloads the full list of people who have tested positive in COVID, and then compares these random IDs downloaded from the server with the random IDs you have stored in your phone. And that means, like, if there has been a match, you have been in touch with somebody with COVID. Hence, what you do is you get a notification, and then you have to call the local authority saying, hey, I got a notification on my phone. Then they will give you an appointment for testing. And then, after that, if you have been tested and you are positive, what happens is they give you a code, and that code gets put in the application, and the application itself uploads your random ID into the server, and that's going to be helpful for others. So that's how you identify clusters. Lambdas are perfect for that, for generating the list of contacts, generating the list of, like things that the phones need to download, sending SMS, sending messages and things like that. And like, if you want to do that with a container, you can, but Lambdas are just perfect because you don't pay for them while they are not running. And also, the cold start of Lambdas have gotten much better. In the API gateway, also Lambdas are what we use with Node.js, of course, as the JWT validator in the API gateway. So in the API gateway, you have to validate your request, and we use JWT for that. So we use the JWT node library for validating the JWT, and we do that transversally regardless of the request. So that means once the request hits the server, it has already been validated by a Lambda, and hence, once the container gets the request, what happens is we know it's a legit request. So there's a lot of trust implicit in there already, and is just a super nice pattern in my opinion. The scalability in Lambda is just out of this world, and out of this world means that at some point one of the Lambdas was using the SDK for Node.js to read secrets from the secrets manager, and we actually choked the secret manager. Just to give you some information, the secret manager has a hard limit of 2,000 requests per second, and we had peaks of 4,000 requests per second. And we found that the hard way. We found that by getting some FIFO2s in the logs, and then debugging the full trace, which that was me the day of the debugging that. You can actually find that one of the services is not replying because it has completely consumed all its bandwidth. And the guys in AWS were like, well, that's super impressive. But the reality is we went in Ireland from 0 users to something like 2.5 million in 3 hours. So that was a very stressful time of my life. I used to have hair, now I don't anymore. So yeah, they're also very, very cheap. So Lambdas are extremely cheap unless they spiral out of control. Let's put it this way. If you're building a system which don't have Lambdas scanning other Lambdas, it's actually giving you a hedge because the Lambda executes, finishes, and that's about it. But if you have systems that Lambdas call other Lambdas, that call other Lambdas, that call other Lambdas, you are going to end up in a loop, or what is even worse, in an exponential loop, and that's going to be very, very expensive. And I mean, very expensive, I mean like several thousands a month. And yeah, that's not ideal. Also, the Lambdas have traditionally been accused of having a lot of latency. The reality is they don't too much anymore. Like you can hot call or cold call a Lambda, and you will get a response below 1 second, assuming the Lambda executes fast. So it's actually an acceptable replacement for a container in some cases, but just be very careful and don't model complex things in Lambda. Just to give you an idea, the thing that I like most on how we use Lambdas in the contact tracing app is how we pre-calculate data in Lambdas. So all this list of people who has been tested positive, and serve them straight away from the API gateway S3 into the customer. So that means a significant chunk of requests from the users do not even hit our code. They go into the API gateway, and then from there into S3, get back the file that the Lambda has pre-calculated, and then send back the request to the client. So that means out of 25 millions a day that we might have in Ireland, 25, 30, I actually don't remember the numbers, over 20 for sure. About 10 of them are just phones getting this list of people with COVID, like random IDs with COVID. So we are deflecting a good chunk of pain through the AWS services. So it's open source, and it is open source because that's a nice way to keep people on the trust side. And obviously, like the worst thing that you want to hear from the government or from the health agency is, hey, great, install this thing in your phone, which it's not going to track your movement, or it's not going to track anything, or it's not going to track, anything on your phone. But trust me, because you trust me before, and it works, totally work always. Like many people will be like, what? I'm not going to install that on my phone. So it was decided to have an open source version. So you can go into COVID Green in GitHub, and you will see my name in there in the infrastructure repository mainly, how we are actively developing and fixing issues and, modifying the infrastructure, the applications, and pretty much everything. And it was built with the build once, deploy everywhere approach. So that means we have 9 tenants. We built one module and one application and one backend, and then we customize it for each tenant. but we had a big problem with Terraform with that. Terraform is just, if you work with Terraform, you end up in some funny situations, like I will show you one in a second, but in general, Terraform is quite awkward at that scale. The apps are React Native, so I remember when I started coding in Java, Android started being a thing, and I was like, oh yeah, this is gonna be, if you become an Android developer, you are gonna win the world. And now I think if you are a React Native developer, you're actually gonna win the world, because you can do React as well, pretty much, and you can build mobile applications. So it's just, fantastic and super easy to understand and super easy to actually, work with it. The COVID Green Initiative is also a Linux Foundation public health project. So it's from the Linux Foundation, and it's there. So yeah, that's pretty much it. Now I'm going to show you the code. Okay, I'm going to do a light walk through the code, but again, it's open source, so you can go there and you will see it. So here's my face. As I said, I had more hair before. I lost all of it with this project. The first and most interesting repository I worked on was the infrastructure. So it's all Terraform. It's all, based on plain AWS services. This is more or less the structure. You can see how we have the DNS hitting the WAF, hitting the API gateway. Sometimes we serve assets from the S3 bucket. Sometimes we go into the backend server and database, Lambdas everywhere, and so on. So what we do is we have a list of variables here that pretty much we inject from the tenants as of the configuration. For example, if your tenant is going to have, like New York, for example, has 18.2 million of potential users, you actually need to pass a different type of database or a different type of CPU profile for the task. So if you search for CPU, not this one, but this one, you can actually, increase that to several CPUs and things like that. So it's highly configurable. Plus, then we have in the modules where we call this module, in the tenants where we call this module, we can have customizations. So it's basically, we have this. This is the dev tenant. This is something that we use for actually, test the configurations. And then you can see how on the dev side, we can see main, and then we call this module with the configuration that we want for this tenant. So the log retention period and so on. So that sounds a bit of too clever, but the reality is it works very well. And you can configure even, how often does the exposure Lambda runs and things like that. So yeah, that's the infrastructure. Then we go into another repository, which is the backend. And you can see how here our repository is just like it's a Node.js application. So we use Fastify first because we build Fastify in-house, and second because it's a fantastic web server. And like lately in Node.js, the reality is Express is super old. Happy with the licensing change, we weren't too sure about it, and there are not really too many other good alternatives out there. So Fastify was. And, this is as close as it can get to well-written software, obviously with a lot of pressure. And, the reality is when we create the server, we have our plugins, and we use the plugin in Fastify, which actually search for plugins in a directory. So all our routes are plugins. So the only thing we need to do to add a new route is come here, create the index. The index will have a decorated server, okay, adding routes, and use the Fastify plugin module, and that's it. Fastify will autoload that, and you don't need to worry about anything else. Every single route has the same structure. You have the index, which is the handler, the query, which are the queries that we need to execute in the database, using another interesting module for preventing SQL injection, and then the schema for input validation. So it becomes very easy to add new routes because pretty much what happens is you just add the folder here, respect the structure, and that's all you need to do. Then aside from that, we have the Lambdas as well, which work in conjunction with all of these. And the Lambdas are, each one of them does a different thing. So we have the cleanup Lambda. So when we send messages with Twilio, with other provider, we need to remove the send messages, otherwise they flood and things like that. 1 second. We have the exposures Lambda. So this is the one that calculates the exposures. So you can see how we remove the ones that we already bundled into S3 and things like that. So you can go and read this code. It's public. It's open source. If you see something wrong, you can contribute to it, and then we will merge the pull request. But it's all based on Lambdas and ECS. So in general, we learn a lot of lessons. So Terraform ecosystem is an absolute mess, and I'm going to show you one example. If you are familiar with Terraform, you know that once you rename a resource, you need to recreate the resource or go in and move manually the state. Actually, they're hiring for DevOps, so that will be a good position. So let's say you go into tag 0.31, which is what we use, which is a bit old, but it's because we couldn't update it yet for this. Your cluster, it's now called default. So if I move into the next one, 0.32, the cluster now it's called primary. So what does that mean? That means that it will destroy my database and recreate it. Or I need to manually move the state from default into primary for 9 tenants, for 2 environments. So that means somebody working on that like a week or more with high risk, because you will be messing with the production state. It's a big no-go for me because we don't save a lot of effort from using a module. It's just gain us a couple of days in the beginning of the project, and now it's pushing us back weeks of thinking about this. So yeah, Terraform has a handle with care label, especially if you're using modules from third parties. Missing a sink in one of the Fastify handlers can destroy the throughput in your cloud native system. So when you miss the async and any of your code throws an exception, instead of resolving into a failed promise, into a rejected promise, it resolves into your application being killed because it does not do the translation between the error and the promise. So that means your container dies and the infrastructure needs to start another container. So that means if you're running 25 containers and you have 20 failing per minute, you're actually doing a lot of work in there and a lot of effort, and that kills the throughput very quickly. So once we figured out that that was the issue, somebody forgot an async, which is normal, working under pressure. We ended up multiplying by 10 the throughput, which is fantastic. Monitoring, it's also harder than you think. There's a sweet spot between the host is on fire, but nobody cares because nobody gets alerts because monitoring is so off-peak that it's scary. And the other side will be, can you stop alerting me on every request twice? Because it can get really, really noisy. And there is an incredibly fine line in there between being super noisy and being not so noisy, which is scary. In my opinion, 2 monitoring levers are the ideal. One on the infrastructure, as of, is my database having a deadlock? Is my database having enough memory? What is the flow on the VPC and things like that? And then I'm monitoring, what is my Node.js loop, delay loop? How many objects do I have in the heap? How many users are registering per hour and things like that? And yeah, that was probably one of the biggest lessons here. Vertical slices of the systems are better than big systems. So we are processing, I was checking this morning, around 120 millions of requests per day. I don't know if you get the scale, but when I saw the traffic flowing through the applications, I was like, oh my God, I got vertigo. Like I actually got vertigo about the number of requests going through. And one thing I'm super glad we did was, instead of building one massive global system, we built smaller chunks across countries and connect them with another service as they need it. So, for example, Ireland and Northern Ireland are connected. So Ireland and Northern Ireland are different systems, but there is one gateway that we call the interop that goes into Ireland in an API, gets the connection, the contacts, and sends them to Northern Ireland. So that actually saved our life, because in some services we are at the limit of AWS. So if we would have gone for a massive, global scale system, we would have suffered quite a lot. So yeah, it's always going to be my recommendation. And it's always as well, be the master of your trade and apprentice of the rest of them. That is because you being the master of something allows you to perform very well on that. For example, I am very fond on infrastructure. Doesn't mean that I am the master, but I try to be as deep in the infrastructure as I can. But I also keep a tag on Node.js and React Native and a few other things. So if there is something coming up, I can fix it. But my domain of expertise is more towards the infrastructure and containerization. But having a team with T-shaped engineers like me, like Jack, who was the backend engineer, Sean, who was on the applications, the other members of the DevOps team, allows us to run a global scale system with very few people. And that to me is the secret. Instead of having, let's hire 200 developers. The reality is you don't have to hire 200 developers. You have to hire 5 good developers and give them autonomy. That's my opinion. And that was about it. So my email is there. As I said before, if you want, I can send you a copy of my books for free. If you have questions, I'm more than happy to answer. My Twitter handle is there. Please follow me or interact with me, or send me messages with feedback. And that's my LinkedIn. That's my LinkedIn handle. So as well, if you want to connect to me, I'm more than happy to do so.